the gateway. It provides what is called a long-range connectivity can be achieved. So these are a few characteristics of LoRaWAN. It is IP connected. The physical layer is based on this. The bit rate is in terms of very low bit rate, 20 kilobits per second. The kind of devices that we use, it is in three clauses: clause A, clause B, and clause C. And the services, geolocation, specific location, and security that can be implemented on LoRa. Okay, so we have seen one technology that can be considered as this one, low power wide area networks. So if you're asked for an example of a low power wide area network technology, you should, LoRaWAN is such a technology. Apart from LoRaWAN, there is another popular one that is called Synkfox. Synkfox again is a low power one technology. So it is Synkfox resemble more a GSM network where you need to have antennas, sensors transmitting to a specific antenna, and then it eventually goes on the cloud. So Synkfox is a network provider conceptually similar to mobile operator. This is what I was telling you. Okay, so the Synkfox network is aimed at IoT application such as remote sensing that transmits small amount of data relatively infrequently. It says infrequently here, small amount of data. However, compared to cellular, Synkfox offers significant cost and battery life advantage. You see here again, to send, if you're using GSM, you need to use a SIM card and then you transmit your data on mobile data, you know, your normal mobile data. This is an option for IoT applications. Some IoT application can use this, but let's say you're sending quite some amount of data, then you will be using a lot of mobile data. The cost of your operating cost will increase. So this is why Synkfox offers significant cost and battery life advantages compared to GSM, compared to cellular. So Synkfox network technology uses ultra narrowband techniques, okay, in sub 1 gigahertz. Again, it is a sub 1 gigahertz technology, okay. In the US, it is 915 megahertz, and in Europe, it is 868 megahertz. You should see the architecture here. It has a wide-reaching signal, okay, because it is using sub 1 gigahertz, it can go very far. Again, here we're talking one hop star topology. That is a node they send directly to the gateway and require a mobile operator to carry the generated traffic. So most often, if you're using Synkfox, it is passing through a mobile operator. It will be passing through, for example, in Mauritius, it will passing through Mighty, for example, or Mauritius Telecom mobile network. So it can be easily cover large areas and reach underground objects as well. So because of the lower frequency, it can pass through objects. This is a typical architecture of a Synkfox network. It is bidirectional communication. It supports, yeah, but there is a limitation. There is something concerning Synkfox. When you are considering to use Synkfox, you need to be careful. It can support only 140 uplink messages a day. If you want to transmit more than this, you will have difficulty with a Synkfox. So 140 uplink messages in a particular day is allowed. Okay, each of these can carry a payload of 12 bytes only, and up to 4 downlink messages per day. Downlink, we don't do much, like from the cloud, you are transmitting a message to your sensor. This we don't do much. It's more from the sensor going to the cloud, but even here you have a limitation of 140 for Synkfox. So this is a limiting factor concerning Synkfox. And the data can go to a Synkfox cloud. There is when you use this technology, you can use its cloud that is provided there. So it uses ultra-wide narrowband modulation. It operates at low data rate, okay, 100 to 600 bits per second in terms of data rate. A device is not attached to a specific bit. Yeah, one difference, for example, when you use your mobile phone on a mobile operator, your mobile phone is always connected to one specific base station, one specific antenna. Okay, whereas here it is not that the sensor, they are not connected to any specific antenna. Whichever they transmit the data, whichever antenna get the communication will forward the communication for you. Okay, so this one is another one. So we have seen LoRaWAN, we have seen Synkfox. Now let's move on to, we are still talking about, let's check the list that we had before. Yeah, we are still talking about sub 1 gigahertz technologies, LoRaWAN, Synkfox, and everything. Here we are talking more about, let's move on to, so these are specific technologies that have been proposed in order to cover long distances for IoT application. But there is also an attempt now, another kind of technology. There is also an attempt, so these are specific proprietary technologies. There's also an attempt to use our normal cellular network in order to, for IoT in general. So if you're talking about 3G and everything, for even 4G, it doesn't fit IoT. Again, for the same reason, it consumes power, it is costly. I've just mentioned in my previous discussion that to transmit on using mobile data can be very costly. If you want to transmit very frequently, some data very frequently, then the cost will increase. So, however, why do you think one of the main reasons of using cellular for IoT? There is problem. The problem is power, the problem is cost. But the advantage, what is the advantage? Oh, I will explain to you how we are overcoming the problem of cost and power. But what is the advantage? What is the motivation to use our normal cellular network for, you know what is cellular? I'm talking about 3G, 4G, and everything. Your mobile phone is already using it. Okay. What is the motivation to use such a network for IoT? Let me put the question to the close. Anyone?
The range that it can cover. We can collect data from remote points.
Okay, but this already, you're right. You're right by mentioning the range. But let's say I could have overcome this problem with LoRa or Synkfox. What is the advantage I get over LoRa and Synkfox? This is what I want to understand, and this is an important point here. Anyone in the class? Another student? Compared to LoRa and Synkfox, why it can be quite an advantage to use your cellular network for IoT. It is not easy because there is problem with our cellular network, the problem of power, the problem of cost. But still we are trying to use the cellular network for IoT. Why?
Mobility, maybe. Like it's gonna be able to move. It's gonna be mobile.
It's a big advantage, actually. Yes, I was not expecting this one, but true. It is a network because, you know, with your mobile phone, you walk around. No, you can be in a car and still using your mobile phone. So it supports mobility. This is whether with LoRa you can be on the move very fast. I'm not so sure. So mobility is something that is supported by our mobile network. So true. I was not expecting this one, but it is true. It is an advantage. I'm expecting something simpler, something more obvious. Anyone? Very obvious. Why we want to use our cellular for IoT? Okay, I'll give you a hint. When you have to implement LoRa, you need to buy those gateways, LoRa gateways that you need to fix somewhere, and then your sensors will transmit to those gateways. So you need to cover more area. You need to buy more of those gateways, and it's quite costly to buy those equipment and place it everywhere and everything. So I put the question again: what is advantage of using cellular?
Base stations already available.
Exactly, it is already deployed, it is already available everywhere. I hardly know any place in Mauritius where you don't have coverage. It is already covered everywhere. So you don't have to invest in those antennas, in those base stations, because those are already there. The infrastructure is already there. We just need to solve our problem of power and cost. Okay, so this is a big advantage actually you get with using an existing infrastructure, using something which is already here, okay, already implemented, already used, already it is already covering the whole of the country. Okay, and if we can use it, if we can harness it for IoT, it would be very good. Okay, so this is advantage I'm talking about here. But however, we still have to solve our problem of cost and power. Let's see. There is something called narrowband IoT. Okay, there are a number of short-range, long-range wireless network protocol which we have already seen. Short-range we have seen Bluetooth, BLE, ZigBee. Long-range we have seen LoRaWAN, Synkfox, and everything. Okay, but each one they have their own limitation. Okay, and it comes to massive IoT support. Especially when you want to support millions and millions of sensors, then those technologies can show certain limitation, and it should be long range. And your friend mentioned about this problem. Now, what if your sensors, they move? You need to support also mobility there. Your sensor nodes, but often we think about sensor nodes being placed somewhere and it remain at the same place. But excuse me, you may have use cases where your sensors move, when your sensors are placed in vehicles or whatever, where they move. So in these cases, then your existing technologies that we have discussed, whether short range, long range, they can show certain limitation. This is why, on the other hand, cellular network are striving to evolve our next generation network that provides the infrastructure to support higher bandwidth, lower latency. We try to get this from our cellular network, higher bandwidth, that is more data rate. We don't need actually higher bandwidth for IoT, but anyway, we are moving toward in this direction when it comes to cellular, but also lower latency, that it takes very less time to transmit your data. This will make them best suited for mission critical, you see, for such kind of IoT application. Mission critical, receive those words very well. Mission criticals, data intensive, where you have to send data very frequently, time sensitive application. You see, for those scenarios, cellular can become an important technology, can become a technology, an interesting technology. But inefficient for massive IoT application that require, you see here, IoT require instead. So we are moving in those directions when it comes to cellular, but what IoT require? Low bandwidth, not high bandwidth, low data rate, related to low bandwidth actually, reduced transmission power. This is what is required by IoT. So telling you that your existing cellular cannot be used directly. Again, I've mentioned about it, the cost power problem. Okay, and for this reason, you cannot use normal, what your mobile phone is currently using. Your sensors will not be able to use it, this mobile operator. So this is why FreeGPP, which looks after standards for GSM and anything, have introduced two new standards in the LTE. LTE stands for Long-Term Evolution Release 13. Two new standards, one that is called EM, that is Enhanced Machine Types Communication, EMTC. EMTC, this is one. And second, Narrowband IoT, NB-IoT. So two standards that, and obviously it's very obvious now what those standards are trying to do, trying to leverage, trying to use our existing GSM infrastructure for IoT. This is what they're trying to do with those two standards. EMTC can deliver up to 1 megabits per second of throughput, so it's okay for IoT, very acceptable. Okay. And full mobility support. Now you understand what this full mobility means. Your sensors can move for a broad range of IoT use cases, for different kind of use, for asset trackers, vehicles, whatever, wearables. So NB-IoT on the other hand, so the two standards that we're talking about here, I've just mentioned it earlier. FreeGPP have proposed EMTC and Mb-IoT. There's slight difference between those two. So EMTC, we have seen that for mobile nodes and everything. Okay, we use it, But NB-IoT, on the other hand, scales down to extreme simplicity. So EMTC is still quite complex, and it uses some amount of energy, EMTC. But if you want lower energy and simple solution where low throughput, it doesn't have high data rate, and delay tolerant, that is, you can afford certain delay. Delay tolerant application means where some delay, you should not have very low latency. Okay, here some delay can be allowed. So in this case, you can use NB-IoT. So you see the difference between EMTC and NB-IoT. EMTC is more for time critical application. NB-IoT is more for simple things, low cost. Okay, but you don't get in terms of you don't get in terms of low latency. Yeah. For example, for meters and sensors and things, you can use this technology. It says here, optimizing for broadest range of IoT application for mobility support. Here, providing for low throughput and delay tolerant IoT case scenarios. Okay, so narrowband IoT is a low power wide area network technology. Okay, it's fall under this category proposed by 3GPP that leverage our existing cellular infrastructure. Okay, it was proposed in 2017, so not that far, quite recent. There are two technologies after EMTC and this is extended cellular GSM IoT. Okay, so and NB-IoT is mainly used for indoor coverage. It can be used for indoor coverage. It is low cost, long battery life, so low power. You see, low cost, low power, and high connection density is made available, but limits the bandwidth to a single narrowband. That is, you don't have high bandwidth basically, because anyway we don't require for IoT. This is basically how it operates. You have your sensors here, NB-IoT terminal sensors that transmit to a base station. You mainly your cellular network base station, and this goes through a core network and reach the NB-IoT platform. Yeah, we said that there are NB-IoT and EMTC. EMTC is more like complex. Okay, it consumes more energy. So LTE-EMTC, machine type communication evolution. Okay. A growing interest in IoT, it is an attractive option for those looking to deploy our cellular network, but need an option for more resource efficient. That can be used for IoT. So LTM, as it is known, will serve application that have never been used before. For example, water meters to agricultural monitors. It's just giving you potential use of this technology. It is power efficient. Yeah, this is advantage of LTEM. This is a new kind of cellular network that we are talking, EMTC. Okay, so it is known as Cellular Internet of Things. Another name, CIoT. So if you say this CIoT, it is Cellular Internet of Things technology. Okay. The E stands for enhanced machine types communication. Yeah, I was looking for this word, extended coverage. GSM Internet of Things. So there are two things we are talking about, EMTC and then ECGSM IoT. ECGSM IoT. Extended coverage IoT is a low power wide area network that has been standardized again by a 3GPP. Okay, it has high capacity, long range, low energy, low complexity. So fits our IoT domain very well. I'm looking for where we mention these two. Here it is. Other 3GPP IoT technology apart from NB-IoT is EMTC and ECGSM IoT. So you see, we are discussing these two here. We have already discussed about NB-IoT. We have discussed about EMTC. Now we are discussing about this one. So actually, there are three, not two. NB-IoT on one side. Then when it comes to EMTC, we have EMTC and ECGSM IoT. These two. So overall, you have three here. So this one can be deployed via software upgrade. So this is an advantage. You don't need to put new antennas, new hardware. You can just at the software level be able to implement this technology. The battery life can go up to 10 years. So this is quite high. Okay, and EMTC, that is EC-GSM IoT network, trials are underway. Okay, so we need to check up. I was checking on the GSM. This is for Internet of Things. You can see this website, Extended Coverage GSM Internet of Things. This technology. Here it is. So based on our cellular network, see the current members are supporting those technology. Let me come back to my slide. Okay. So Orange, for example, is piloting this this technology in France. Can be used for smart agriculture and everything. This is a typical cellular IoT designed to provide coverage. So these are the advantages: reuse existing. Yeah, you see here, we don't have to implement new infrastructure. We are using our existing cellular. Okay, it is 4G-like. On our mobile phone, we are already using 4G. It supports roaming, so the mobility is there. Okay, so it is designed as a high-capacity long range. We have already seen this. It is future-oriented cellular IoT network. You can see just graphic of the same thing that we have just discussed here, cellular IoT. So this is 4G, which is used by your mobile phone. This is EMTC. This is specifically for IoT, and NB-IoT, which is specifically for IoT. You see here, EMTC can give you up around 1 megabits per second, whereas NB-IoT is lower data rate, 100 kilobits per second. But both, they are based on the cellular infrastructure, our existing cellular infrastructure, and it support mobility. These are the two advantages we are getting here. More or less the same thing in terms of the network performance. I've told you about NB-IoT, it can give up to something like 100 kilobits per second. You see NB-IoT at the top and down EMTC. NB-IoT, in terms of peak throughput, it can reach that level of kbps, okay, in terms of 100 kbps, whereas here we're talking about megabits per second. So it says something here, NB-IoT EMTC standards evolution path to 5G. Okay, 5G is still under deployment. Okay, we don't have really full implementation of 5G yet, but the promise of 5G is that it will support sensors. On your 5G network, you can have millions of sensors communicating using your existing cellular infrastructure. This is a primary use cases for IoT. You see a smart parking, smart metering, smart street lights, air quality detection. So all these can be implemented using NB-IoT. Here you see new smart health, shared bicycle, pet tracking, smart agriculture, wearables. So all these are use cases for NB-IoT. You can see here comparison of the different GSM technologies, if I can, cellular technologies, okay, LTE, EMTC, NB-IoT, EC, extended coverage, GSM IoT. So these three we have just discussed. Okay, all of them is from 3GPP, not IEEE. Normally, previously I've discussed about IEEE standard, but this one is from 3GPP. The kind of data rate it can give, latency. Let's check the latency. EMTC, 10 millisecond. NB-IoT, you notice I have told you that this is more for delay tolerant application. So when we talk about delay tolerant application, so it can go up to 10 seconds. After 10 seconds, that you will know which value, what is the value for your sensor. Okay, here we are talking about quite low latency, 10 millisecond. Here we're talking about quite high latency, 10 seconds. So you should be able to read this table and understand it this way. This is the bandwidth. This is the data rate for the technology. Again, the same thing, but we have combined Synkfox and LoRaWAN in this table here. Synkfox is private. Okay, LoRa is open, but it is you need to buy the necessary equipment and everything to be able to use it. Synkfox, you need to pay the provider itself. Okay, EC, extended coverage GSM. You have LT category 1, category 0, and then Emtc and Mb Iot. So all those technologies we have discussed, mainly for long range communication on IoT systems. Okay, you can see it again here. LoRa on one side, ZigBee short range, LoRa long range, Synkfox long range, 10 kilometers. You are talking in terms of 10 meters. NB-IoT in terms of 15 kilometers. Okay, and some providers are mentioned here. Here you see even those technologies we have discussed earlier, ZigBee, Thread, which was a 6 low wireless PAN technology, BLE, Bluetooth, Wi-Fi, AH, you recall 802.11 AH. So all these are technologies sub 1 gigahertz on this side. These are some metrics we use when we talk about communication technologies for IoT. We have already discussed about this. I've talked about latency, time it takes to transmit the data, the throughput, number of bytes it can carry for you. For IoT, you have noticed we talk in terms of kilobits per second, so it's not that high. Okay, overhead that it has. Scalability is an important issue because we need to support large number of devices. You have power and range is always some important consideration. Okay, so we have reached nearly the end of this discussion. Recall, I've given you assignment 3. If you remind me, assignment 3 was on assignment 3.
Sensors, actuators.
Okay, sensors and actuators. Let me have. Where's the Google Classroom? Yeah, assignment 3. Assignment 3 was on sensors and actuators. Assignment 4, I think the submission deadline was, okay, 3rd of December on Thursday. It has already lapsed. Now you have to tackle assignment 4. The deadline is 10th of December. That is next week. You have the deadline for comparison of IoT platform. Now already your 5th assignment and last one for this semester will be compare and contrast the following 5 IoT wireless access technologies in terms of the power, in terms of their range, in terms of the latency, in terms of the technical specification. So in terms of the equipment and everything, you need to compare those technologies. Those very popular technologies. You need to perform a complete comparison for this assignment. I will post it on the Google Classroom anyway. The deadline, I will inform you accordingly. So you already have one on 10th of December. Most probably, I will see if I can give you up to 18th of December. So as you wrap up, you finish with all your assignment for this module, for this semester as well. Okay, so this is it. You have, don't forget, you have your class test on Thursday. The class test will be on chapters 1 to 3, okay, and lab material as well. Know your codes for your Arduino programming. Okay, we have spent quite some time on Arduino programming, so know the codes well. We have mainly worked with the LED examples and in building circuits and everything. So mainly it will be on these kind of question only. Okay, I think this is it. Any question from this lecture on access technologies or with respect to your class test? We will meet next week on Monday, normal. Okay, so I'll try to see for the application. I wanted to have you on campus. Which lecture you have apart from my lecture? You have distributed system, is it? Cloud distributed system, is it?
Yes.
Okay, this one is still online, no?
Yes, but next week I think we have a test on Monday for distributed system.
Okay, let me talk to, if you have a test, then it is better. The test will be in the morning, early in the morning, if I'm not mistaken.
Yes.
Okay, so then it should me if you have this test face-to-face. So then I can have a lecture itself. That is, we can have our discussion in a classroom. okay, for the loss for the application part. And this was the loss, but as per your module specification sheet, you'll notice we have completed all the 4 chapters. Now we are moving toward the application 1. Okay, we won't be able to cover everything about the application, but anyway, we'll continue with it. Anyway, this is not the 15th week, by the way. Which next week will be week 12, if I'm not mistaken, 11 or 12. So this semester will continue in January. So we have time for our application. I was thinking that we have reached the 15th week. It is not the 15th week. So we will complete our program for semester 1 without any issue, without any problem. Okay. So on Monday, most probably we'll have face-to-face a lecture in a classroom where we are going to discuss about the application areas. One specific application area that I will be choosing, and I will explain in the class how we are going to do it as well. No issues about it. So any question for concerning the chapters and concerning clusters? Assignments you already I will be marking it accordingly. It is already available on the Google Classroom. Class tests, you're going to have it on Thursday at 9. The room I still need to check with the admin, and we'll let you know on the Google Classroom Monday. Okay, if you don't have any question, we can end here. Okay, so I'll see you on Thursday then. All the best and revise well for the test. Pass on the message. I've seen only 17 students here. Anyway, when we'll do the test on Thursday, I will comment on it. All of you have put your name on that attendance sheet. Yes, make sure you have your name on that attendance sheet. I'm keeping track who is attending the different lectures. I've shared a link on the chat for this, and as soon as the lecture finish, I will remove the attendance sheet. So make sure you have your name on the attendance sheet. Okay, let me stop the recording first.